Okay, so today we're going to divert a little bit from doing digital audio and dive deeper into the scale object so that we can do exponential mapping. Exponential mapping is going to let us get a more expressive mapping of key velocity to amplitude for digital audio. So we need to talk about it. We're going to do a little quick patch here. Um, so we can see the output of our results. We're going to add in an itable. And let's make it a little bit bigger so we can see stuff. And I'm going to hold down the shift key so I keep it in a square just to see. And that's good. Okay, so then what we want to do is scale 0 to 127 onto 0 to 1 for amplitude. And that's going to look like 0 to 127 onto 0 as a floating point to 1. But we're going to add a fifth argument, which is the exponential base value. Now we're going to add 1 as the exponential base. And what that does is the difference between a linear curve and an exponential curve is an exponential curve may change more slowly for some values and quicker for other values. So it's not a linear ramp, but it's actually a curve. So what can we do to do this? Well, we need to be able to sort of quickly get 128 values from 0 to 1. So there's a great object called Uzi. We'll send out many bangs as fast as your computer can. You tell it how many. And so whenever it receives a bang, it's going to send out 128 more. Then we're going to count those bangs. And it's going to go from 0 to 127 all the time. So we're going to move this over. We're going to come out. I mean, it's going to go by so fast we don't even really need to see it. But first thing is we're going to get a scaled value. And because I want to be able to write it to an itable, the itable doesn't handle floating point messages. I'm going to take my floating point and convert them back to a scale of 128, or 127 being my maximum. So if everything that comes out gets multiplied by 127 as a floating point, and then that floating point output gets converted to an integer, then I can pack the count and the value to store at the count. And that's going to all go in. So I'm going to lock the patch and click, and I get a straight line. 0 to 127 gets mapped onto 0 to 1 in a linear fashion. So that's linear mapping. Now let's unlock the patch and add in a floating point number that we can put as an argument or a message to the exponential base value, this fifth argument of scale. And let's type in 1.01. Hit return and run the Uzi again. And now you see that it's a curve. It's an exponential curve, which means it doesn't get down to 0 over here, and it's not linear. We can kind of change this. Let's do something big. Let's go to 2. And you can see that it's 0 values until the very end. It starts making a big change to get up to 1. So that's a little too much of a curve. 1.04 makes a nice kind of compromise. Lower integer inputs, so key velocities, are going to change less noticeably. Then as they start getting into this range around 50, 55, they start increasing at a faster rate or by more for each value. And it does that as it goes up. And that's kind of how we hear amplitude. We need to hear bigger amplitude changes or have bigger amplitude changes at the top of our range to be heard as the same thing as these small values at the low range. And you can play around then with what you like your prime or your perfect exponential curve. I can try 1.06, stays smaller for longer, and then increases quickly at the end. I kind of like the 1.04. Just go back. Now, I should be able to make an exponential curve in the other direction so that it starts fast and slows down as it gets up. And so to do that, I would go below 1. Let's say 0.94. And I do that in, and it gets back into a straight line. And this is a problem that scale is by default set in classic mode. So let's unlock the patch. Click on scale, and it's down here in this value, classic. And this lets it work with some older patchers for scaling, but it doesn't show us like true exponential scaling. So I'm going to unclick that, deselect it, go back in, unlock, and now type in, say, 0.9, run this again, and you start to see the curve going in the other direction. It needs to be more on the low end here, so let's say 0.5. And you see I get the quick up, slows down. 0.25 gives me kind of the reverse of what I was dealing with, just in case you want to make those kinds of curves. For amplitude, it's going to be better to do above 1, and I think between 1.04 and 1.06. And here's the problem that you get. Now that it's out of classic mode, it takes a much bigger exponential curve, or much bigger number to get the same exponential curve. So it's just a question of what you're used to and how you think about your exponents. For our purposes, it's probably easiest to not have to worry about the classic being on or off. It's going to default to be on. And then we can think in terms of this 1.0 something being our curve. And it works out. So I'm going to stop there for this one. Just helps you think about this. I'm going to use this in the short term to do some velocity scaling to amplitude for the car plus strong video. So I'm going to post in a little while. That's it. Bye.